Welcome to Practical AI. If you work in artificial intelligence, aspire to, or are curious how AI-related technologies are changing the world, this is the show for you. Thank you to our partners at Fastly for shipping all of our pods super fast to wherever you listen. Check them out at fastly.com. And to our friends at Fly, deploy your app servers and database close to your users. No ops required. Learn more at fly.io.
Welcome to another episode of Practical AI. This is Daniel Whitenack. I'm a data scientist with SIL International, and I'm joined as always by my co-host, Chris Benson, who is a tech strategist at Lockheed Martin. How you doing, Chris?
I'm doing very well. How are you today, Daniel?
I'm actually doing amazing. So I'm not in my normal location. I'm down in Orlando, Florida. So One thing is it's sunny outside and I can be outside without suffering. But also, well, I'm in in-person meetings here with some of our collaborators and partners, and they wanted me to do a demo today. So I got up early this morning at 6 a.m. before hotel breakfast, and I threw together a quick demo, and I used Modal for that. And there's literally someone that stood up out of their seat and clapped after the demo. So our guest today is Erik Bernhardson with Modal. And so basically Erik is making me look good in all respects. And I'm pretty excited to talk more about Modal and share it with everyone today. Welcome, Erik.
Hi, thanks for having me. I'm excited to talk about Modal or anything else.
Yeah. I think, Chris, do you remember quite a while ago? I don't remember when this was. Maybe Erik, you remember, I think you wrote a blog post about building data teams or something like that. I forget exactly what it was, but I remember Chris and I talking about it on the podcast. I'll have to see if I can find it back in your blog. But
yeah, that was in the summer of 2021. I wrote the blog post.
Yeah. So we should have had you on the show then, but I'm glad that we get to have you on the show now. So you describe Modal as an end-to-end stack for cloud compute. So I guess one big question maybe to start things out is cloud compute isn't new, but it definitely can be complicated depending on what you're trying to do. What got you starting to think about the set of problems that you're addressing with Modal? What got you going down this path?
Yeah, it's kind of a longer story maybe, but I've been working with data for 15 years or maybe more, most of my career. Initially I was at Spotify for 7 years. I built the music recommendation system there and open sourced a vector database called Annoy and a workflow scheduler called Luigi. But it did kind of everything from deep learning to business intelligence to large scale big data type Hadoop stuff. And then I was the CTO at a company called Better for 6 years. Managed data teams, but also managed other teams. And so as I was thinking about starting a company, I kept coming back to data. And my starting point was really just it's hard to work with data. And I feel like data teams don't have the tools they need. And initially, I was super agnostic as to what to build. I kind of frankly wanted to rebuild everything, which is not particularly realistic.
Maybe in a lifetime.
Aspirational, megalomaniac maybe. But what I realized was that at least if you want to rethink a lot of the data stack, a good place to start is at the bottom. So I almost sometimes joke that I'm kind of grudgingly had to start, it's like a spite startup, and doing this work at the most lowest level, which is to, solve the compute problem of I have code and I want to deploy it in the cloud. And why is that so hard? I don't know. But, it's a big problem for many data teams is, just the problem of taking code and scaling it out or scheduling it or running it on GPUs or, setting up web endpoints or whatever it is. And really focusing on that problem as building this core foundational layer. That's very abstract and very general purpose. So that's also why our website, I think, is a little bit confusing the first time. But in particular, what I would say we've been focusing on the last 6 months is online inference. So it's a lot of machine learning, AI models, focusing on that use case as a sort of initial starting point. But Modal always to me had this promise of running almost anything. It's almost like a Kubernetes in the cloud.
Yeah, and one of the interesting things to me, I think, where like maybe it took me a second for this to like sink in, but once it did, it like was a really encouraging thing for me was like I have my code locally and I know how to run it locally, but then like you have this sort of concept of like these decorators within Python code that kind of take your code and like you run it like Python, main.py, whatever. But actually something like the moment I realized, okay, well now this function is actually not running locally. Like I just did some sort of like batch inference or something with this script and didn't like, my fans aren't going on my laptop because this is actually running somewhere else. Could you describe like, there's a lot of ways that you could have gone about this sort of lower level of the problems that data teams face. There's a really fundamental piece of this, which is like the local to cloud or local to deployment like cycle. And with Modal, that seems very, very quick. Like, how did you zero in on that kind of workflow?
We built something that architecturally looks something like AWS Lambda, right? Like it's like function as a service. We take code and execute it in a serverless way in the cloud. The starting point, like the reason why I ended up going down this rabbit hole of doing that, really the whole like, serverless, runtime is really kind of thinking about like developer productivity and developer happiness. And my sort of philosophical observation as CTO for many years is that developer productivity, I think, is very often like well understood in terms of feedback loops. And so, and in particular, there's a sort of, as you write code, there's like almost like a nested set of for loops. It's the innermost loop of like you write some code, then it's a syntax error, then you fix it, and then you run it. Maybe you have some unit tests. But then like there's like these like outer loops that are often like, okay, let's like deploy this to the cloud, or like, let's like run this on a massive data sets. And that's when the iteration speed gets like very, very slow. And so you look at data teams, like they're often like particularly exposed to these feedback loops because they have to run on large data sets, or they always have to run things in production. Like you can't really run like things on like synthetic data as a data team. Like you have to kind of deploy it into production or like run it on a real data set. And so it really frustrated a lot of data teams. It's like that sort of like very slow iteration speed. It's like I write some code, now I have to like, create a container, push it to the cloud, then go and click on an interface or like, merge, some pull request or whatever. Then like, my container fails. Now I have to go and look at logs or whatever. So I started thinking about like, what if we bring the infrastructure into that like innermost loop, like the loop of like, okay, you just write code and then you like immediately run it, but it actually runs in the cloud. And, in order to do that, we realized we can't do this with Kubernetes. We can't do this using Lambda. Like we basically have to build our own infrastructure that takes code and can launch containers, maybe hundreds of containers in the cloud in a few seconds. So we went very deep, down that rabbit hole and built basically our own container runtime, our own file system, our own container builder. Luckily, I'm not, afraid to go deep and like solve like kind of tricky, container problems and dealing with Linux and file systems. But that's like a lot of what we had to build in the last 2 years is that foundational level, like that runtime. But the benefit is like now we have this, super nice developer experience where you can just take code locally. You can spawn 100 containers in the cloud in a few seconds, like running the latest code in the latest container.
It sounds fascinating. I'm really interested in it, but I want to ask you to step back for a second with a follow-up and bridge a gap of understanding for me. You were saying like can't do it with Kubernetes, can't do it with AWS Lambda, and I believe you, but I don't know why, and I'm imagining that maybe a few of our listeners don't know why either. Could you kind of tell us what it is like, because a lot of them, their companies are in one of those big three providers, and to kind of show them, you kind of demonstrated with the user experience quite well a moment ago, but could you talk a little bit about like what was falling down in those kind of more mainstream big three kind of approach, Google, AWS, and Azure, so that we kind of understand that? Because you made a statement, I'm with you on that, but just bridging it.
Yeah, and first of all, like I'm like the world's biggest AWS fan, right? Like, we run everything on AWS. And like I love it for the capabilities it brings me as a developer to run things at scale. Yeah. Developer experience in AWS has never been particularly good. And so,
true.
Like I've been banging my head, for years against like, AWS documentation. And in the end, I usually figure it out, but it's a pretty jarring experience. I think in particular, the problem with both Kubernetes and AWS, or like Lambda or EC2, et cetera, that we saw, like, either, for users to use it directly or for us to build on top of that is just the iteration speed. Like, so if, for instance, in Kubernetes, let's say you want to run something in Kubernetes in production, going from code locally. Well, now you have to first build a container. Then you have to do some sort of Docker push to some registry, right? Then you have to kick off a Kubernetes job. Then, you have to go and look at the logs of that Kubernetes job. And by the way, kicking off a Kubernetes job, like that often like entails like, the kubelet worker, like pulling down the Docker image. And so we were like looking under the hood and trying to understand how like Docker works. And Docker, it's an amazing piece of technology, like, for the sort of, the new way of thinking that it brings to the table around like, insulated containers. But it's quite inefficient in starting containers. Like, most containers end up having lots of data that's never actually read. Like there's like, thousands of like time zone files of like, locale information about, time zones in Uzbekistan or whatever. Like you're never going to read those, right?
Unless you're in Uzbekistan. Sorry, just getting that in there.
Yeah, on this, whatever, or uninhabited islands. Like there's like time zone information about uninhabited islands in like, the standard Linux distribution. Like, okay, like great, but like get them out of my Docker container. But the other thing is also Docker is quite inefficient and like it has this like layer thing. But like other than that, it doesn't really deduplicate information. And so what we realized is that what if we like rethink how, those containers get pushed and pulled and we end up building our own file system? We deduplicate the content by computing a checksum of every file. That's actually sort of similar to how Lambda works. But Lambda is also not fast enough in the sense that like if you publish a new Lambda, it still takes about a minute for you to be able to run it. Lambda also has other limitations. It doesn't support GPU, it doesn't support long-running jobs, etc. So those are all the reasons like why we ended up deciding we can't build this on top of Kubernetes or Lambda or any existing solution. Also not Docker. We ended up using lower level primitives instead and building a lot of it ourselves.
And are there specific things about, and I sort of like in my own experience and using Modal have experienced this, but from your perspective, I would be interested to hear, like, you talked about kind of moving towards this use case, like the use cases around machine learning, around AI as being kind of like very well suited to this workflow. Of those types of workflows, have any sort of like added benefits and or challenges that maybe like, running a web scraper or something like some other sort of like use case, which is related to data, but maybe not involving sort of like serialized model files and inference and GPUs. Like, what are those things about these machine learning or AI workflows where you think like either there's specific challenges that people have that are solved by this kind of quick cycle workflow versus just kind of like other data related workflows?
Yeah, I think we focused a lot on online inference recently. So basically, let's say you have a model, could either be some off-the-shelf model from Hugging Face or some fine-tuned model that you have yourself, and you want to deploy that. And in particular, if that model uses GPU, the set of vendors that support that is somewhat limited. And the other reason why it's is also cost. Traditionally, if you go through the Kubernetes or EC2 route, if you want to deploy a model inference endpoint, you have to spin up an instance that sits idle for most of the time. You can set up autoscaling, but autoscaling is pretty slow. So moving to serverless makes a lot of sense from a cost perspective. And so I think that's the other reason why we've seen a lot of, it's not just us. There's been, I saw the Banana was in the previous episode, for instance, like there's a couple of other vendors that are also focused on this. I think cost is driving a lot of that, the demand for serverless vendors for GPU compute specifically. I also think it's something that just came up in the last few months where like a lot of people ended up realizing like, we're very good at training models, like building, custom stuff. We don't want to deal with infrastructure and running this in production. And so there's been a lot of demand for vendors like Modal, where they can just take a model and publish it to Modal and run it in production and not have to think about, auto scaling policies and have to think about setting up, web endpoints and dealing with security groups and all that stuff. That being said, I mean, Modal kind of going back to its roots, like we did, it's not just online inference. Like we started out focusing a lot on what I think of as like embarrassingly parallel problem, like this idea that like you have something you want to fan out and do a lot of stuff in parallel. So besides online inference, Modal also does a fair amount of batch inference or sort of parallelizable things. Like a lot of people actually use this for web scraping. Other people also use this for things like computational biotech, large-scale transcoding. You can also use this for various types of simulations or backtesting, that kind of stuff. So there's a pretty wide range of things that Modal does well. But I think right now, like the user experience of online inference is like 9 out of 10, I would say, at Modal. The user experience for like batch inference and large-scale like parallelism is like 8 out of 10. We're working on a lot of the other stuff like data pipelines, like building more complex support for scheduling and that kind of stuff. Where right now, like it's good, but it's not quite yet where we think the long-term potential is.
So Erik, I mentioned, and full disclosure to everyone in the world, I'm a huge fan of Modal and have been using it a lot and building things in it, including the side project I'm working on, Prediction Guard. And I think I just counted, I'm in the interface now, I have 129 Modal apps deployed right now.
Wow.
So I want to try to like describe from my end, like, it's hard because like this is an audio podcast and like talking about how things work without like showing something visual is a little bit tough, but I want to do my best at trying to describe like how I would describe it. And then I'd love like you to fill in the gaps or correct me if I'm wrong at any point. So if you think about running something in Modal, you can write a Python script, like let's say app.py or whatever. You can have functions in that script. And then actually one of the things I love is like dependencies is a really annoying part of particularly AI and ML workflows. So you can decorate certain functions in your code with like stub.function and then define a modal stub in your code, which is essentially like referencing a container with certain dependencies in it. And then when you execute your code, you say Python app.py, and when it gets to executing that function in your code, which is decorated with the stub, it actually doesn't run it locally. It spins up a container in Modal and runs that in the cloud. So you can do this either by just calling that function, or you can actually deploy then your app and have that function be accessible as like a serverless function or a web endpoint for your other applications or your other APIs to access. So I don't know if I did a great job at describing that, Erik. That was my initial attempt. Feel free to make that more coherent.
No, I think that's exactly right. Like I think you touched on a couple of points of Modal, where we maybe think different about infrastructure than other. In particular, this guy Swix wrote a great blog post about it. It's called the self-provisioning runtime. And I think that's like, to me, it's been kind of putting words to an idea that I always had around, like, it's sort of similar, like if you ever use like a service like Pulumi, for instance, like, or like Terraform or something like that. There's sort of idea that like infrastructure is code. But like Modal has always gone further than that. It's also like infrastructure and the app code, like just put it together in the same code and have like the app itself define the infrastructure it needs to run. And so with Modal, in code, you define, the containers you need, including Python dependencies or any other like binary dependencies you need. You can have different functions using different containers calling each other, just like Python functions, right? And it just like provisions itself. Like you can say, this function should run on a GPU. This function should have 16 CPUs available. This other function needs 128 gigabytes of RAM. Like in code, there's zero config in Modal. There's like not a YAML file. Like there's nothing you can configure in Modal. Like everything is in code. And to me, it's all, goes back to this idea of like how do you make developers productive in having the fast feedback loop is I think traditionally we've had to give that up and basically make engineers run things locally in order to get the fast feedback loops they need. But then the problem is like later they still need to deploy it to the cloud. And then you have a whole set of issues that then break because the cloud is running in a different environment. And so this goes back to what I said like maybe 20 minutes ago. Like what if you can take the infrastructure and bring it into the innermost loop of how you iterate? Then you solve this problem of having different environments because it's always running in the cloud. And it's fast enough that like it feels, some people even say Modal is faster than running things locally, even though it's running in the cloud. You never ever have to think about these environment conflicts because it's always running in the exact same container at any time. And it's fast enough that you don't have to like this like frustrating thing where you have to build containers and push them around, and like you sort of get the best of two worlds. You get the developer productivity of running things locally, but you have, the full power of the cloud, and all the power of, containers and GPUs and like whatever, right? I don't know if that makes any sense.
Yeah, it's So Chris and I have talked about this at like certain points in the podcast. I have always like really had this disdain for like maintaining a whole bunch of like local environments as well. Like I'm not a Conda user. Like I have like very minimal setup locally on my machine. And one of the things I think I kind of grasped onto is like, oh, well, I can develop now locally with Modal and just like import OS and import JSON and like kind of normal-ish things and import Modal. But when I need to access transformers or PyTorch or like some random other package that like normalizes index scripts or something, like I actually have like zero concern about like setting that up locally to test, because I can just add that as a dependency in the Modal function, and that runs in the cloud in its own container. So I actually never even have to install that locally. Now I could do that maybe before like using like a local build of a Docker image or something. But that, again, like you were talking about, Erik, has another cycle associated with it, which is also annoying. Yeah.
Yeah, it's kind of annoying.
So yeah, I love that this, like, I can just think through, like, my imports are minimal. Like I can even run like a PyTest, right? And it's just testing as it's going to run in production, right? Because it's running in a container in the cloud already. It's running that function. Yeah, so that's kind of like a lot of my love, I feel like, that I've enjoyed about it. What are the surprising ways that you've seen people use Modal that maybe like have been unlocked for users that were really either difficult for them before, or like, oh, I didn't expect people to do this with Modal? Have you encountered any of those things that stand out?
I mean, model inference in itself, like, kind of, was a little bit of a serendipitous thing for us. Like, we didn't expect that people would do that. In general, like, we thought of Modal primarily initially as like more of like a batch workhorse, like, something that helps you scale out. But we've seen a lot of traction on online inference and model deployments. And so for that reason, we're focusing a lot on improving startup performance right now, because when you're doing online inference, you have to spin up containers very quickly. You also have to load models very quickly. And especially when you're dealing with GPUs, there's a lot of overhead of copying models and GPUs, et cetera. So getting that down has been a big focus of ours for the last few months. I guess another thing I've been like sort of surprised by is we enable the functionality to set up webhooks pretty easily. So in Modal, you can define, make this function exposed to the web and give it its own URL. And now you can call this URL and it triggers something in Modal, triggers some Python code. People started leveraging that for like building like full-blown web apps on Modal, which I was kind of surprised by, like graphical UIs and all kinds of stuff, and like hosting whole UIs. Because I never anticipated like that being like a use case. I always thought of like, people are going to use like, whatever, like Vercel or Heroku maybe for something like that. But that's been sort of interesting to see that a lot of people are using that. And so it's pretty promising. Like maybe there's something more to be done there. Like I tend to think like our bread and butter is like machine learning and AI and like, data pipeline. So I don't want to go like all in on like sort of building more like a web hosting platform. But I think there's something interesting. And it's sort of similar along the same lines. A lot of people have been using us more for sort of job queues type things, like, more like almost like as a replacement to salary. The idea that like they can create a Modal function and then they can like in-queue work for it, and they never have to think about scaling or sort of deployment and productionization of salary, like job queues. And that was also something we didn't really think about, but a bunch of people have been telling us they actually do. So that's kind of cool.
So I got a follow-up question here, and you've both sort of covered it to some degree already, but as the person who has not yet had a chance to use it, I'm really curious, and I'm imagining there are a few people listening as well that are wondering, could you take us, Erik, like through kind of a classic workflow with Modal? We've done that with other technologies that you may have heard on other episodes and stuff, but I'm trying to get in my mind, Daniel is doing it all the time, but I've been left behind a little bit on this. Kind of just take us through a typical AI ML workflow on Modal, just verbally, like what the steps are, just to kind of show us that simplicity. People probably going to be thinking about whatever they're on, previously if they're on some other platform, just as a point of comparison about how you're doing that. I'm just kind of curious if you can, any example is fine.
Yeah, I mean, we've optimized a lot for making it possible to deploy things and run things in the cloud in a few minutes. So it's actually pretty straightforward. Like in Modal, you basically take any Python function. So let's say you have a Python function that maybe uses Hugging Face, just as an example, and it uses some off-the-shelf model for maybe stable diffusion. And so let's say you have a Python function, existing Python function that uses Hugging Face, and it takes a prompt and it returns an image. Now you can decorate that Python function in Modal with a special decorator and then annotate it and say, use this image, and then define an image in code using a special Modal syntax. You can also give us a Docker file, but it's actually, we support almost everyone just does it in Python internally. So in code, you can say, basically, use Debian Slim and then install these Python packages like transformers and accelerate and diffusers and a few other things. And then annotate the function to say, use that image. And then that's pretty much it. Now you can run on the command line. You can do Modal deploy or Modal run. And then it just takes that code, builds the container if it doesn't exist, and runs it in the cloud. And that could typically take less than, if the image is already built, it typically takes about a second to take the code locally, spawn a container in the cloud, running that code. It works for any Python function.
I mean, that's dead simple right there.
Yeah, and it works for any Python function. And you can run pretty much any code you want because we support fat containers, meaning you can install Python packages, you can install FFmpeg if you want to transcode some video. You can install, whatever thing you want. And we have a lot of functionality for manipulating images and building dependencies and doing pretty advanced stuff as a part of that too. Pre-baking models into images is something people want to do sometimes to optimize cold start performance. But yeah, getting started with Modal, we really optimize for having that sort of magic experience the first time you try Modal. Making it easy to just install the Python package, set up a token, and run code immediately in the cloud. We want that first experience to be magic and sort of set a tone for what Modal is and the fact that Modal we think is a better way to work with infrastructure in the cloud.
So one of the things I was wondering about, which I guess it was a surprise to me, I didn't really think about it when I was first using it. So I don't know, everybody has their different setup, but usually I've got my code editor over here and I've got my terminal over here on maybe another monitor or something. So I've got both up and I was writing it was a webhook in Modal and I had it Python app, whatever. And when it's a webhook, then the code runs and then Modal gives you this link where you can ping a development webhook. And of course, I never get my code right the first time around. So I bring up Postman or something and I try to hit my web, that link. And of course it I get whatever error. And kind of without realizing, I just went over to my code and I fixed it and I just saved the file. And I saw over here in my terminal, it just redeployed and gave me the link again. I think that was a really cool, surprise for me, I guess, is oh, I don't even have to I can just keep this up over here in the terminal. How does that work exactly? And was that something that you stumbled upon, or because I found that a really satisfying way to develop, because where it's oh, I just keep this up, I keep modifying the file and trying it until it works. And then I can just Control C and say Modal deploy, and then I'm done, right?
Yeah, for sure. I know I'm harping on it, but kind of think about feedback loops and the sort of iteration speed. As a CTO, I manage a lot of different teams. I manage data teams and front-end teams and back-end teams. And it's sort of interesting how different disciplines of software engineering have figured out their own iteration cycles, the ability to get feedback loops very quickly. Back-end engineers tend to write a lot of unit tests. That's their way. They write some code and then they run all the unit tests, or maybe they run a specific unit test that you know is going to break. And they have that sort of way to go to get the fast feedback loop. You go to front-end engineers, they have kind of a setup you just described. They have one monitor with the website and then one monitor where they like write code. And when they save, it just hot reloads the code. So I feel sometimes data and backend people don't give enough credit to front engineers. They have really figured out a lot of stuff around software engineering for fast feedback loops. And actually, if you look at the modern tool chain for front engineering, I actually think in many ways it's more advanced than any other part of software engineering. And so that is the sort of feedback loop that I wanted to have with Modal. And what I think makes engineers happy is that super snappy feedback. You just have to save code and then it's live in the cloud. Yeah, so we built that specifically for the web serving part of Modal, because that's something you kind of want to have, is that ability to, we don't, it's maybe less you sort of visual feedback, but it's the ability to deploy something in the cloud and then you can hit it with Postman or curl or whatever immediately. I mean, under the hood, it's not super complex. Actually, refactored it yesterday. It's kind of funny. We just monitor the file system, and then when we see that any file was updated, we just reload the entire app in a sub process and live patch the app running in the cloud. So it's pretty straightforward. We had a lot of that already built. So
I think the problems you've been solving for like the past 2 years are probably really complicated for you to like loop that into like the category of really simple problems. I think that would probably be quite complicated for many people.
Yeah, for sure. I guess like it's like simple in the sense that it's sort of, we already built, so much of the like underlying complexity to like make that relatively easy to support the hot reloading. Like the fact that we already built like so much complexity around like take code and deploy it to the cloud and do that very quickly,
right.
That's a very nice foundation to then like leverage.
It's your sort of bread and butter.
Yeah, like building that, fast container, fast file system stuff. There's a lot of cool stuff that unlocks.
So this is a particularly interesting episode, I would argue, for me and probably for quite a few of our listeners that listen regularly, because we're talking about something, and Erik, we have the privilege of you as the person who's created this, but we also have Daniel, whom I've been working closely with and our listeners have been listening to, and hearing Daniel's passion and him building his own business on your platform. And we talked to lots of different companies. And so it definitely has intrigued me in a way that not every different company owner, if you would, has. I'm kind of curious. I'm thinking about it from a slightly different perspective from Daniel, but you've really got me wondering like how to make this happen. I work at a big company, as you know. We have big investments in kind of the big cloud providers, as all large companies do. What are good strategies for companies to say, okay, we have so much in these other big names and stuff that are out there. How do we start using Modal effectively? What are the kinds of things you've seen your larger customers do in terms of migration over, or things that you might recommend that enable something of a migration to be more seamless, less painful? Because normally when you think of large company migrations, they are almost always fraught with pain and misery and challenges for the IT crews. So how do people get to this thing that we're hearing about today and mitigate all of those problems?
Yeah. I mean, first of all, like admittedly, like we're fairly early, and so a lot of our customer base is early stage companies, like starting from a clean slate, who have absolutely zero infrastructure, and that makes it a little bit easier.
It does,
in part because there's like nothing legacy that they have to port over, in part also because they're just desperate for tools, and so the sales process is a little bit easier for us. I find that like the conversation when we talk to bigger customers is obviously like quite different. First of all, there's often an existing data platform that's already built in-house. There's, of course, also a security compliance question, and that's something we're working on. That I think long-term, there's a lot of really cool stuff you can do around VPC peering and other things to enable the big companies to have the security guarantees that they need. But I also think it's a separate conversation where, like, at a bigger company, it's like there's one person who's a decision maker who has the credit card. There's another person who built the data platform who, now we're saying, oh, actually, we shouldn't use that. We should use Modal instead. And so, it's a tougher conversation. And then there's maybe a data scientist, and a third person is a data scientist who really want to deploy models. They don't really care about the infrastructure, but they heard good things about Modal. I tend to think in those conversations, it's about like finding like a niche use case that's like, low risk, that, doesn't sit in sort of some sort of critical path of like, the whole business relies on this. And, so it could be some sort of greenfield, something new, deploying a model or a very simple pipeline, something that, maybe doesn't touch like super sensitive data or have like super critical like guarantees. So some like researchy project, like that's typically where I tend to start is, and often trying to find people, data scientists or machine learning engineers who feel like the platform team doesn't really have time for them. Like, they want something that lets them iterate quickly, without having to bother the ops team. Those are probably the easiest conversations to have, with like the bigger companies.
That's good guidance. I appreciate that.
I think it's very fitting that like the platform is, at least right now, and please correct me if I'm wrong, it is very Python centric in terms of like the development workflow and what's supported. Do you see this being sort of like you said, that you can support so many different types of jobs and apps in Modal. So, on one side, you could say, well, this could become like very general purpose in some ways, or it could like fill a really niche gap that obviously it is starting to fill, and just do that really well and like continue to kind of go deeper there. What do you see as kind of the path forward? Or maybe it's a both and with, some things coming sooner than later?
I think of Modal as my 20-year project. Like I'm finally building a tool I always wanted to have. And like, I want to spend, the rest of my career doing that ideally. So my sort of end goal is to build, a very general purpose set of tools that help data teams be more productive. That being said, kind of like what I said at the start of this show, like I sort of realized like that's a, almost like megalomaniac vision. Like I think it all comes down to like in practice to finding something that resonates with customers and, drives growth and validates demand, and then sort of sequencing and kind of layering on like sort of adjacent product over time. We tend to think right now, like we have one sort of use case and one sort of target persona that works really well right now, which is, deploying online machine learning inference. That I think, is an area where we see enormous amounts of demand and traction. So kind of how that, fits into sequencing, I think, an obvious next step for us is to make fine-tuning and training easier to do in Modal, but also thinking about, like pre-processing, scheduling, retraining, so it happens on a loop on a regular basis. Maybe thinking about like, how do you move your data sets into Modal to some extent too, like hosting more like stateful applications. I think there's like a long list of sort of, like layering on like step by step, more and more advanced features and gradually expand to take over. And because I think the demand is there, like, and no one wants to have this like 35 different point solutions that they have to integrate themselves, right? And a lot of the data landscape today, I think, is very fragmented. And, as a result, a lot of data teams have to integrate like so many different vendors and kind of duct tape them together. Like I think there's a big case to be made for either some sort of consolidation or some sort of like defragmentation of the space where fewer vendors do more. So long term, that's absolutely my vision. Is to we're starting with this like place right now. Similarly, in terms of languages, right? Like you mentioned, Python versus other languages. We think Python right now is a great place to start because that's 90% plus of data teams use Python. But definitely think long term, a lot of the infrastructure that we built is, low level and it's written in Rust. It doesn't really care about what stuff it's running. We think it could be, great to add support for TypeScript or R or Go or Rust or whatever. So there's many different axes of this, like in terms of like how we think about sequencing and expansion.
I'm just saying, you saw me raise my hand. I love Rust. It's my current favorite languages.
Nice.
Go and Rust are on the back end, and so. But let me ask you a question that came to mind as you were going through that. As you're kind of exploring the world, and you have certain areas of focus, but there's also some kind of able to stretch out depending on different parts of the strategy you have. How do you see, kind of, to use a very generic open term, the edge out there, things that are not in the cloud? Do you see you doing anything in the future that would be kind of edge-based, or do you see yourself more as the cloud partner for things that might be out on the edge and you have APIs and such available to those? How do you conceive either working with or including the edge in your overall strategy?
I think edge is primarily useful for like very, very latency sensitive applications. And that's probably a segment of the market that we just feel like that's not what Modal is going to be good at. Because, if you do things in like WASM or V8 isolates, like, in that case, you can make it like kind of fast enough. But, the way we focus on serverless right now is sort of fat, traditional like Linux, distributions in containers or VMs. And that just has, it's always going to have some non-trivial overhead, maybe a second, maybe like eventually we can get it to a few hundred milliseconds. I think to sort of edge workloads that people talk about, like, that's when you really need like 1 millisecond, right? Like, and you're really trying to, either you're doing some like IoT type, like controlling like devices for manufacturing, or you're doing high performance like CDN, like SEO type stuff, where you want like your website to be absurdly fast. Those are the types of workloads I don't really think Modal is suited super well for, and I'm more than happy to let other vendors dominate that space. We tend to think on the time scale of like a few hundred milliseconds and up. That's where we focus right now.
No, that's a great answer. And definitely, I mean, trying to address every problem, out there in the larger space isn't a successful approach. So hearing when I talk to people and I hear, no, we're not going to go there, I usually take that as a very good thing in terms of focus and good strategy. So good to hear that.
Cool. Yeah.
Kind of as we wrap up here, I'd be curious to hear, obviously you're very passionate about this project. You want to work on it for 20 years. This is your life's work, it sounds like. What are the things that are on your mind right now in terms of the things that you're excited about seeing happen in Modal? And over the next year, what are you most excited about seeing come to pass as you continue working on the project?
The thing that I personally spend the most time on is probably figuring out the ergonomics of the SDK itself, in code. How do you express programs that execute in a distributed way in the cloud and still making it feel intuitive and easy to the user without having to think about the fact that this function runs in a different container than this function. We've made that work reasonably well for online inference, but I think when you go to training and start dealing with file systems, there's certain things that are still a little bit gnarly, and I'm working a lot on that right now. So making that user experience good and sort of intuitive, I think is really important. On a similar note, Modal right now is somewhat janky when you run it inside notebooks for some particular reasons. I'm not going to get into it, but it's something I definitely want to make. The user experience, if you're running Modal inside a notebook, I think should obviously be, we need to fix that too. It's fine. It's not terrible, but I definitely don't think it's quite yet where it is if you run Modal in the script. There's a lot of this backend stuff. We definitely need to scale this up, 10x or 100x the scale we are. We see a lot of demand. Modal does not have a publicly available sign up right now. You can sign up and you go on a wait list. And part of it is that we want to have a little bit more control over the scale. There's a lot of work we need to do on the back end to build the foundational, architecture running all of this stuff. It's a very hard problem. It's building, essentially our own Lambda or our own Kubernetes. There's a lot of work we need to do on GPU support, and in particular, cold start with GPU models and fast loading of GPU models. So there's a lot of cool work. We're spending a lot of time on there, especially when it comes to containers and in general, isolation and VMs. It turns out that supporting GPUs in a secure way in a multi-tenant environment is quite hard. So we're going very deep and I'm reading about Linux device drivers and CUDA and trying to understand all of those things. Yeah, I mean, those are all the things we're working on. I think in a year's time, I think Modal, we'll see a lot more traction, Modal for other things than just online inference. We're going to see a lot of people using Modal for training. We're going to see a lot of people using Modal for parallelization. I think we're going to have, much more customers on the enterprise side. Right now, we're focusing very much on the startups, but we're laying a lot of the security and compliance work to be able to go up market. Those are some of the things I'm pretty excited about.
Yeah. There's a lot to be excited about. And please pass on my personal thanks again to the Modal team for making me look good today and recently. And really excited about what you're doing and appreciate you taking time to chat with us.
Yeah, of course. I'm also very excited about this. So always happy to talk about it.
Thank you for listening to Practical AI. Your next step is to subscribe now, if you haven't already. And if you're a longtime listener of the show, help us reach more people by sharing Practical AI with your friends and colleagues. Thanks once again to Fastly and Fly for partnering with us to bring you all Changelog podcasts. Check out what they're up to at fastly.com and fly.io. And to our beat freaking residents, Breakmaster Cylinder, for continuously cranking out the best beats in the biz. That's all for now. We'll talk to you again next time.